Hello class, today we are going to use trig ratios to find the sides of a right triangle. Alright, so now just to remind you, trig ratios, that is sine, cosine, and tangent. I have our mnemonic up here, SOHCAHTOA, to help us remember what those ratios are. So real quickly, before we go into finding the sides of a triangle, we're just going to remember what those ratios are. So here, I'm going to find the sine of angle A in triangle ABC. Sine, remember, is opposite over hypotenuse. So this is for angle A. So opposite of angle A is 3, and the hypotenuse, well, the hypotenuse is 5. So this is just going to be 3 over 5. Cosine for angle A, so this is the C-A-H. So this is adjacent over hypotenuse. So the cosine, adjacent leg. So the leg right there next to A is 4, and H is hypotenuse again, so that's 5 again. So 4 over 5. Tangent of angle A, so tangent is the TOA, so that's opposite over adjacent. So for angle A, opposite to angle A is 3, and the adjacent leg is 4, so this is 3 over 4. All right. Now, I want to show you this. So here I have another triangle. This is triangle A, B prime, C prime. That should be C prime, not C prime prime. Oh well. All right, we're going to find the sine, cosine, and tangent for angle A again. All right. So here, the sine, opposite over hypotenuse, opposite of A. Now we're looking at 6. Hypotenuse is 10. So that's 6 over 10, right? Well, 6 over 10 simplifies to 3 over 5. Always want to simplify your fractions, right? Cosine, that's adjacent over hypotenuse. Adjacent, this time when I would be 8, because we're looking at the orange triangle, the whole thing here. So 8 over hypotenuse of 10, so that's 8 over 10. And again, we do want to simplify that down, that's 4/5. Tangent, opposite over adjacent, is going to be 6 over 8. And do always simplify your fractions, so 6 over 8, that is 3/4. You know what? Let's do another one. There we go. All right, so again, sine is opposite 9 over hypotenuse. Now the hypotenuse is 15, so 9 over 15, which simplifies down 3/5. Cosine would be adjacent, so adjacent side is this whole long side here, which is now 12 units long, again, over the hypotenuse, which is now 15. So 12 over 15, which is 4/5, because it simplifies. Tangent. Tangent is opposite 9 over adjacent, this whole side, which is 12. Again, simplify down, that's 3/4. You know what, let's go ahead, let's do one more. One more. And some of you are already starting to find a pattern here. So sine, opposite of angle A is 12. Hypotenuse of the whole big thing now is 20, so 12 over 20, which simplifies down to 3/5. Cosine is adjacent over hypotenuse. The adjacent, this whole long leg here, is 16 over the hypotenuse, which is now 20, so 16 over 20, which simplifies down to 4/5. And tangent is going to be 12 over 16, which simplifies down to 3/4. If you'll notice, on every single one of these, the sine of angle A is exactly the same. The cosine for angle A is exactly the same. The tangent for angle A is exactly the same. And the reason for this is because angle A has not changed. And these are all right triangles, and so these are all similar, and so the ratios of the sides are all the same. All right, because of scale factor, right? Because they're all similar triangles, and so the scale factor keeps the ratios the same. And so what that means is I could pull up this little bitty triangle here. I have no idea what any of the lengths are, but I can still find sine, cosine, and tangent because they all have angle A. And I know that the sine of angle A is 3/5, the cosine of angle A is 4/5, and the tangent of angle A is 3/4. All right, and so I don't have to know what these sides are because I know it's angle A, so I know that's the sine, cosine, and tangent. And this is very, very useful because what this means is the tangent of any angle is a set number. Or the cosine and the sine, these are all set numbers. And so if we know what those numbers are, then all we need to do is know one of those sides And then we can figure out, basically, it's what our scale factor is, and that will give us the actual side lengths of our triangle. All right, so let's take a look at this. Okay, so here I have triangle ABC, and it tells me that the length of AB is 23, and the measure of angle A is 34. I want to find A and B. Now we'll start with A because, why not? So what I want to do, I'm going to use my ratios here, sine, cosine, and tangent to find this value. So I'm going to use angle A because that's the angle I have a measurement for. If I'm using A, where is A, side A, from angle A? Well, side A is across the thing. It's opposite angle A. So I want the ratio that has opposite in this. So that's going to be either sine or tangent. And which other side do I know? Well, I know side AB, which is the hypotenuse over here. So which one uses opposite and hypotenuse? Well, that's this one here. That's sine. So what I want the sine of angle A. Now, I actually have a measurement for angle A, so I'm just going to put angle A. I'm going to put 34. I'm going to put that in parentheses. Sine of 34 degrees equals opposite over hypotenuse. So opposite is side A. I don't know what that is. I've got to figure that out. Over the hypotenuse, which is 23. All right. Now, I want to solve for A. So I need to get A by itself, which means I've got to get rid of that 23. So to do that, how do we get rid of that 23 there? Well, we just multiply both sides by 23, right? And so that gives, so times 23 times 23. And so what that gives me is 23 times the sine of 34 degrees equals A. And now I'm just going to take this and I'm going to stick it into my calculator and see what answer I get. On your calculator, you end up with A is equal to 12.86143677798, on and on and on it goes. All right. Your trig ratios are always going to, your trig ratios are almost always going to be these great big awful decimals. They're irrational, like square roots. So we're going to round this off. We're going to round off to the nearest hundredths place. And so A is approximately 12.86. All right. So that's A. Now let's find B. Well, let's take a look at first which ratio are we going to use for B. Well, now we do know A, so we could use Pythagorean theorem here. Now that I have two sides, I want to find that other one. The problem with that is A is not exact. It's not an exact number. It goes on forever with this irrational decimal. And so we don't want to use a rounded number. We saw that before we used rounded numbers and it gave us slightly different answers. And our answers were kind of wrong because they were rounded off. So we want to use exact numbers, which means I don't want to use A at all if I don't have to. So I'm going to use another one of my ratios. So let's see. I'm looking for B right here. Still, I'm going to use angle A. So B is right there next to it. So that's adjacent. So I'm going to use, let's see, that's either cosine or tangent because those both have adjacent in it. And the other side I'm going to use is my hypotenuse over there. So I'm not going to use tangent, going to use this one. So I've got cosine is adjacent and hypotenuse. So the cosine of 34 degrees is equal to my adjacent, B, which I've got to figure out, over my hypotenuse, which is 23. So once again, I want to multiply both sides by 23, so I can get that off the bottom there, times 23. And so B is equal to 23 times the cosine of 34 degrees. Just going to stick that into my calculator and see what it gives. And this gives me B is approximately, because I'm going to have to round this off, because again, this is a great big hideous decimal, is approximately 19.07, approximately. All right, and there's that. Not too bad, right? Now, one thing that you do need to make sure your calculator is in degrees. These are degrees. There is another unit of measure for angles, which is called radians, which you probably have never used before. When you get up into calculus and things like that, you're going to be doing things in radians. Here, we're going to be dealing with degrees. We might get to radians later on, but probably not. All right, so, and that'll be later. So make sure your calculator is in degrees. A lot of calculators default into radians, so depending on what your calculator is, you may need to find the settings there and change that to degrees. But then all you're going to do is you're just going to type this into your calculator. So 23 cosine of 34 and 23 sine 34. All right? Okay, let's do another one. Here, I have now that angle B is 78 degrees, angle A is 42 degrees. I want to find side A and I want to find side C. So let's start with A because, again, why not? So A is the side I'm looking for. I have angle B and I'm looking for side A. Well, A is right there next to it, so that's adjacent. So let's see, adjacent, that's either going to be cosine or tangent. And which side do I know? Well, I know the 42, which is over there. That's opposite the angle that I have. And so opposite is right there. So I'm going to be using tangent. All right, so let's set this up. So we have tangent. Tangent of what? Tangent of our angle. So tangent of 78 degrees equals my opposite, which is 42, over my adjacent, which is A. There we go. So now this one is a little bit weird because my variable is in the denominator, and I don't really like the variable in the denominator. So we got to get the variable out of the denominator, and the way we're going to do that is going to multiply by the variable. So I'm going to multiply by A here, going to multiply by A there, and I now have this cancels out. So A times the tangent of 78 degrees equals 42. But again, I don't want the tangent. I just want A by itself, right? So I need to divide by all of this. So I'm going to divide by the tangent of 78 on both sides. Tangent of 78. And so now what we're going to do, A is equal to 42 divided by the tangent of 78. And I'm going to take that and I'm going to stick that into my calculator and see what it says. And so I get an answer that A is approximately, again, we're going to be rounding these, 8.93. Approximately. Not exact. It's rounded off because remember, all of these pretty much are going to be irrational numbers. Okay, so that's A. Now I need to find B. Sorry, not B. I'm looking for C now. C. Still using angle B. So if I'm looking for C, C is the hypotenuse. All right, so that means I'm going to be using either cosine or sine, one of those two. Well, which side do I know? Well, actually, I know A and B, right? But again, A is rounded off, so I don't want to use that because it's not the exact number. So I'm going to be using the 42, which again, that is opposite right there. So I'm going to be using sine. So sine of my angle, sine of 78, there we go, equals opposite, which is 42, divided by my hypotenuse, which is C, which is what I'm looking for. So now if you'll notice over here, when we did the division, all that happened, we took this tangent and it moved to the bottom, right? See right here? The tangent moves to the bottom and the variable comes out to the top. So I'm going to shortcut this, and C is equal to 42 divided by sine of 78 degrees. Okay? Because that's what's going to happen. You'd multiply by C, then you divide by the sine of 78. So we can just shortcut this and just divide by the sine of 78. So again, I'm going to take this, I'm going to stick this into my calculator, and we'll see what we get. So I put this in my calculator, and I get that C is equal to approximately 42.94. Again, this is very rounded off. Now, I do want to stop and ask myself, does this make sense? Right? because C is the hypotenuse, so it should be my longest side. Is it my longest side? Yeah, 42.94 is bigger than 42, so it is my longest side. Let's see, 78 degrees, so this would be a very small angle. And do I have a very small side? Yes. Opposite my smallest angle is my smallest side. So always check that to make sure that that makes sense. Now, just to refresh, to recap, when you're doing this, first you got to figure out which ratio are you using. To do that, which sides are you dealing with? Over here, I'm dealing with opposite and hypotenuse, so that's sine. For A, I was dealing with adjacent and opposite, so that's tangent. Don't forget your angles. It's always the ratio is going to happen with the angle. So tangent of 78 degrees, sine of 78 degrees. All right? Then use your ratio, opposite over hypotenuse, opposite over adjacent, adjacent over hypotenuse, whatever it is. And the thing is, if your variable is on the bottom of your ratio, you're going to end up dividing. You divide by the sine, cosine, tangent. If your variable is on the top of the ratio, then you multiply. That was the first two we did, right? So if your variable is on the top, you're going to multiply. If your variable is on the bottom, you're going to divide. And you're just going to stick it into your calculator and see what it tells you. All right? Hope you found that useful, and I will see you in the next video.